Okay, hey there, Cal class. How is everyone doing? We are now in week 2 here. I didn't post a second video last week because it came to my attention that section we're covering just got scratched from the AP exam. So I had to rework the schedule a little bit. We will go back to that, but that's for more SUPA stuff instead of the AP exam. So as it comes to the AP exam, this is the last section we have to cover. And I've broken it up into hopefully just 2 different video segments that we can cover half here and half in the next one. This is the less visual, more doing math portion, which sometimes is done second, but I don't have the resources to get the first half done right now. I'm going to try to get that done later this week. With that being said, let's get to some differential equations, sometimes referred to as diff EQs. So for this class, we're only going to be talking about separable equations, which will look something like this. dy over dx equals x squared over y squared. And they'll ask us to solve this equation. So what this is going to entail is, as the name implies, we need to separate the variables. We want the x's to be on one side and the y's to be on the other side. So I'm going to start off by getting rid of these denominators. I'm going to multiply by that dx term on each side, as well as a y squared on each side, which is going to leave us with y squared dy equals x squared dx. And once we get to this step, we have successfully separated the variables. Yay, so exciting. Now we can actually do some integration to get rid of the dy and the dx. So we can integrate on both sides. This integral ends up being pretty easy. But since we're integrating both sides, notice we're ending up with a constant on each side. We can kind of combine those constants. You could say it's constant 2 minus constant 1. However, since they're both constants and we don't know what they are, we can just say that they are some constant, c. I'm actually okay with this being the answer to the solved differential here. Sometimes certain questions, specifically on the AP, will ask you to specifically solve for y equals. If that was the case and they wanted you to keep going, we could multiply by 3. However, 3 times a constant is still just some constant. So a lot of manipulation of the constant throughout this question. And then we could finally end up saying that this is just the cube root of everything. That's only if they ask you specifically to solve for y equals. We had solved up here. Both of these answers are correct, though. Now, to get to part B, where it says find the solution to the equation that satisfies the initial condition y of 0 equals 2. So that's saying that the y equals 2 when x equals 0. It's kind of breaking down what this whole thing means. So y equals 2 when x equals 0. And we could use either of these equations to help us solve for this. I'm going to use the bottom one since we already have it as y and x. So 2 equals the cube root of 0 plus c. 2 equals the cube root of c, so c here equals 8. And our final equation would look like this. And we'd be good to go here. Some of you may be saying, well, this would pump out a different constant if we got here. The c is technically different here. However, if you went through and solved for y equals, we'd still end up with the same equation. Okay, that's pretty much going to be how differential equations work. Everyone got it there? Okay, so there's really only two types of differential equations that we're going to come across. One's where it's f of x times g of x, and one where it's f of x divided by g of y, and that's what I should have said on the first one. And how we go through and solve these is we need to separate variables. So in the first one over here, we could divide by that g of y, and on this other one, we multiply by dx, and then you integrate both sides. Over here, this is kind of like the case we just did. Notice that for both of these, we're multiplying or dividing to get terms to the other side. It's not like we can add or subtract functions. That is not how separation of variables works. You need to actually multiply by these terms. So for instance, if it was f of x plus g of y here, you can't subtract that g of y over. That's not how separation of equations works. Let's go through two more questions and then we'll get to some homework. Okay, so we have another fraction one set up for us here where we can see x terms are on top here, y terms are in the bottom, and we have the dy over dx. So in order to solve this, we need to separate variables, which means let's get y on one side, let's get the x's on the other. So we can go through, get the y's over on the left-hand side, and the x's on the right-hand side. Since the variables are separated, we can now integrate both sides. And notice the integration can only be done here because everything on the left or right side is in terms of just y over here or just x over here, which allows the integration to actually happen. Okay. So we end up with a y squared here. We end up with sine of y here equals, this is going to be x to the third. The 2 is in front. And the move generally, if we're integrating both sides, is to just put the constant on one of the sides. You don't need to go through that big game that we did in the last question of constant 1, constant 2. We can just say, oh, the constant's over here. And once we get to this step, you may be saying, well, how can we solve for y? We have it inside the sign, and the answer is we can't really solve for y equals here. So this is in fact just a good answer at this point. So we'd be good to go here. Not so bad, right? Okay, last one. What's different or interesting about this one is we don't have division, first of all, and second of all, the notation's different here. We have it written as y prime, which in terms of differential equations is usually a little trickier to think about. So I'd say the first step whenever it's written as y prime is write it out. It's the derivative of y with respect to x. dy over dx. Okay, at this point, let's do our separation of variables. The y has to be divided in this case. So we have a 1 over y dy equals x squared dx. Now we can integrate both sides. And we're here at this point. ln of y equals 1/3 x to the third plus c, which is a good answer unless they're specifically asking you to solve for y equals. So I'm okay with this answer. If they're asking you to go a little bit farther, which sometimes the AP does, let's go through and solve for y equals. So that means we need to get rid of this ln, which means we need to e both sides. Which that is not necessarily very pretty, but it is an answer. And if we're looking for kind of constant manipulation in here, there's a little bit more. When we're adding in the exponent of some exponential function here, this function is really the same thing as e to the 1/3 x to the third times e to the c. That addition is really like multiplying. And so e raised to some constant, what that really is just some constant in general, which is typically denoted in the front. Kind of weird, right? We can split up this addition in here, just make it multiplication, but e to some constant is still just a constant. So this is typically how this type of equation is denoted. Okay, so we've gone through a couple questions like this. Let's look at a couple for homework now. So ones I've written out for you guys to do are out of Stewart, an addition that goes deeper than our textbook goes. I think in the edition I'm using here, it's chapter 9. In other ones, I think it's chapter 8. Either way, here are 12 questions for us to look at. Please hit me up with any questions or concerns that you have about these, and I'll go over a handful of them on Wednesday if you get any feedback to me either today, tomorrow, or early on Wednesday. Okay, stay safe, everybody. I'll see you soon.